Everyone, welcome to day one of Embedded System. So, in our previous session, we learned about the roadmap for our Embedded System course. Okay, so what are we going to learn today? Here are the topics which we'll be learning today. We'll be getting to know what is embedded system and why it is needed, and a very important topic, which is the difference between C language and embedded system. Okay, these isn't just another subject or a topic, it's actually a way of thinking. And as we go through this, you'll start noticing, or the way you look at every embedded or electronics device around you is going to completely change. Okay, because usually when we hear the word computing, we immediately think about laptops and smartphones, right? That's the common thing. But the reality is, computing is happening everywhere around us. It's inside your washing machine, microwave, cars, even even the inside very simple devices like a fan and remote also. Your washing machine knows, it can figure out when the clothes are dry based on their conditions. Your cars can decide when to deploy an airbag within milliseconds, right? Now, if you really think about it, how are these devices making decisions? They don't have any screens like laptops, they don't run applications like phones, but still they behave intelligent. And that's because these are not just machines, they are embedded system. Now, let's understand what is an embedded system is. In simple terms, an embedded system is a combination of hardware and software designed to perform a specific task. And that specific task is very important because, unlike general purpose computers like your laptops, which can run multiple applications, an embedded system is built for one dedicated purpose. It doesn't try to do everything. It focuses on doing one job continuously, reliably, and efficiently. It keeps taking inputs, processing them, and giving the outputs all in real time. So instead of running apps, it is constantly running logics that interact with the physical world. Now, here's something that might surprise you. There are billions of these tiny systems working silently around us right now. In fact, around 98% of all microprocessors manufactured today are used in embedded system, and only a very small percentage actually goes inside the traditional computers like laptops and servers. So, when we talk about these programming really impacts the real world, this is where most of us is most of it is happening. For today's PPT and free resources, please join our Telegram group. The link will be provided in the description box. Now, let's get back to the topic. In standard software development, you mostly deal with screens, right? You work with datas, user interfaces, applications. Like, you write a code and the output appears on your screen, maybe like an text or an image. But what happens in embedded system? It's very different. It's very different, I would say. Here, the output will be physical, like a single line of code which you write can turn on an LED, it can turn on a motor, it can control the temperature, and it can activate a buzzer. Okay, so when you in this coming decade, with the rise of electric vehicles, smart cities, and surgical robots, the world won't just need a person who can build websites. it desperately need people who can bridge the gap between code and the copper, between the softwares and the silicon. Okay, so now here is the catch. These systems we are going to work with are extremely small and resource constrained. Okay, your laptops might have 8 GB and or 16 GB of RAM, a powerful processor, storage, and also operating system. But a microcontroller, which is the heart of an embedded system, might have a few kilobytes of memory and a much lower processing speed. That's 1,000 times smaller compared to your laptops. And still, these tiny chips manages to control complex systems like with high reliability. That's actually what makes embedded system both challenging and interesting at the same time, because you have to do more with little resources. Now, naturally, this leads to an important question. Okay, if resources are so limited, we can go and use like Python languages, right? But the answer is not really, because Python's language is like, they are very high level languages. They need more memory, and they usually depend on an operating system. But in embedded system, we often don't have that luxury. We need an language that is fast, efficient, and very close to the hardware. And that's where embedded system comes in. Embedded C allows you to directly interact with hardwares. These things like registers, memory locations, and also input and output pins. It gives you control at a very low level, which is exactly what we needed in embedded system. Okay, so before we move forward, where I'll show you the difference between C and embedded C, I want you to think about this. If you could give brain to any dumb objects in your house, what would it be? Keep that idea in your mind, because by the end of this course, you will have the skill to actually build them. Okay, now let's get into the topic. If you open an standard C textbook, the first thing they teach you is to print a hello world, right? But here is the reality check. If I take this tiny microcontroller chip and I'll tell it to print something, okay, where it is going to print? It doesn't have any monitor, it doesn't have a console, also, right? This is the first big shift in your mindset, because in standard C, you are writing code to a computer, but in embedded C, we are writing code to a circuit. Okay, for more free resources, please join to our Telegram group. The link will be given in the description box. Okay, so let's get back to the topic. As I mentioned, in standard C programming, you are writing code to a computer that has an operating system like Windows, Mac OS, and Linux. That operating system acts like an protective layer, right? It manages memory, handles files, prevents crashes, and gives you error messages when something goes wrong. But what happens in embedded C? Most of the time, these there is no operating system for us, obviously, and you are working directly on the hardware. This is what we call bare metal programming. So there is no safety layers, there is no pop-up messages or error messages coming, there is no system protection. If something goes wrong, the system might just stay silently, and that silence, no output, no error, is what makes debugging an embedded system more challenging, because you have to figure it out on your own. In C language, your program usually ends up with an written zero, right? When we write our first code, we'll start with int main, and obviously we'll end up with return zero. Right, what it does, it runs the code, it completes its task, and it just stops. Correct? But in embedded system, this won't work, right? Think about a system like elevator, car, or an temperature control. They need to keep running continuously, right? They need to constantly monitor the input, and they need to respond immediately. If the program gets stopped, the system gets stopped, and that is not the thing which we accept, right? That's why embedded system uses something called as infinite loop, which you can see in the screen. Instead of ending the program, it keeps running forever. It continuously checks for input, processing data, and updates output again and again. This loop is efficiently the heartbeat for the system. As long as this loop is running, your system is alive and it will be functioning. Okay, the moment it stops, the system is efficiently dead. So when you look at embedded system as a whole, it's not just about writing a code, it's about building systems that interact with the real world. It requires a different mindset, a deeper understanding of the hardware, and also a strong focus on efficiency and reliability. It's a combination of logic, electronics, and problem solving. So we are at the end of this session. Okay, so for free resources and for more updates, please subscribe to our channel and also join our Telegram group. Thank you for joining us in our first day of embedded system course.